Good morning, everyone. This is John Mark Sarmiento from the University of the Philippines, Mindanao, and I will be presenting to you determinants of CASI adoption across EGP, behavioral insights, and its implications to scaling up. This paper is co-authored with Maria Feyrola Robson, Rene Villano, and Roy Murray Pryor. CASI technologies, or the conservation agriculture based sustainable intensification technologies, deal with poverty and environmental challenges. It is introduced in South Asia through an A-sharp project. Despite their agronomic and economic benefits, the adoption in the region is relatively poor. And that can be because CA is a medium to long-term management practice. And we also found that there are behavioral factors that affect farmers' decision to adopt CA. And this is supported by Van Holtz and Posthumus. Now, given the large investment in CASI and its potentials, there is a need to understand the underlying reasons for the low adoption in this region. This paper will examine the determinants of adoption of CASI technologies in the eastern gangetic plains of South Asia. We did a survey across 5 districts in 3 countries, Nepal, India, and Bangladesh. It involves 2,510 men and women farmers. The Malda survey is not included yet in this analysis. The partners follow the survey protocol. It is a paper-based face-to-face survey, and it commenced prior to the pandemic. But during the pandemic, we continued with the data collection following health and safety protocols. We also have the data entry protocol, which the partners also adhere to. And then in our data analysis, we used 5 approaches. First is the Cronbach's alpha, and then the t-test, the logic analysis for the adapter versus non-adapter, and its marginal analysis. And lastly, the Mann-Whitney U test, which is a non-parametric test. So this is the CASI adoption profile across the South Asia. We asked the farmers regarding their adoption decision in the previous year, whether they adopted conservation agriculture-based sustainable intensification technology. So we have 2,510 samples, 283 in Bihar, 361 in Cooch Behar, 343 in Nepal, 746 in Rajshahi, and 777 data points in Rangpur. Now, we asked the farmers regarding their core technology, CASI technology that they used. So most of the farmers are using the ZT, or the zero tillage or strip tillage maize, and that's 9% across the 3 countries, and which is followed by the ZT-ST wheat, including happy cedar, and the ZT or the ST mung bean, lentil, mustard, and kidney bean. This is followed by the ZT-ST rice, the rice transplanter, and the bed planting with 3% adoption rate. And the list are the multi-crop seed drill and the unpaddled transplanted rice. Now, district-wise, we also found that in Bihar, the popular technology is the ZT wheat, and for Cooch Behar, it is the ZT maize, followed by the rice transplanter and the ZT wheat. In Nepal, it is the ZT mung bean, while in Rajshahi and Rangpur, farmers there are usually using the ZT or the ST, strip tillage, maize, and wheat. We also asked the complementary technology that they use together with the core CASI technology. And the popular technology is the crop residue retention with 7% adoption rate across the 3 countries. But primarily, these are being adopted in Cooch Behar in India and in Nepal. The other complementary technologies are the land laser leveler, the early seeding rice or for other crops, mulching, the conservation agriculture befitting varietal replacement, the CA-based crop diversification or rotation, and the CA-based intercropping. And then finally, we describe also the CASI adoption in terms of whether the adapter is using one core CASI technology or more than one core CASI technology. And most of the adapters with 19% adoption rate across the three countries are concentrated in Cooch Behar, India, with 46% adoption rate. And this can be broken down into 22 farmers or 22% of the farmers adopting one core CASI technology, and the remaining 24% are adopting more than one core CASI technology. So firstly, what we did is we selected the behavioral constructs with high Cronbach's alpha, and the behavioral constructs that we considered are the self-efficacy, dual systems theory, collective efficacy, the social capital defining groups, and the outcome expectations and expectancies, information seeking behavior, social identity theory defining a good farmer, and social support. And we also have the goals and aspirations, social capital defining community, social identity theory for personal, and the attitudes. We use the test scale, and the cutoff point is 0.75 Cronbach alpha. And so we considered the behavioral constructs, self-efficacy, dual systems theory, collective efficacy, social capital for group, outcome expectations and expectancies, information seeking behavior, the social identity theory for good farmer, and lastly, the social support as those constructs with high Cronbach alpha, which we include in the model in the succeeding analysis. So we first compared these behavioral constructs in terms of their score for adapter and non-adapter. And we found a significant difference between these six constructs. And what we found is that the adapter have consistently high rating for these constructs compared to the non-adapter. This is the descriptive analysis that we used for our logit model. So this is in terms of CASI adoption for the previous year. So what we have here is comparing the mean and the standard deviation of the non-adapter and adapter with 712 non-adapters and 357 samples for adapters. So aside from the location variable, in this case, the base is Bihar, India. We have Cooch Behar, Nepal, Rajshahi, and Rangpur. We also have the variables gender, age, civil status, whether married or non-married, years of farming, farming occupation, education, which is an ordinal level from 0 to 5, and the number of male household members, female, dependent, and the number of household members who migrated, their membership to farmers' organization, and their sources of information for new technology, which is a multiple response question, which includes personal, social, formal, traditional media, the internet. And also we ask for their access to credit, for extension, attendance to CASI-related workshops, and their knowledge on CASI, which is an ordinal scale from 1 to 4. And finally, the behavioral constructs with high Cronbach alpha, which are the self-efficacy, collective efficacy, social support, information-seeking behavior, outcome expectations and expectancies, dual systems theory, social identity theory, and social capital for group level, which is measured in terms of a Likert scale. So our logit analysis suggests the following variables that are significantly affecting CASI adoption. So in terms of location variable, we found that Cooch Behar and Rajshahi have high CASI adoption rate compared to the base, which is Bihar, while Rangpur have lower adoption rate compared to Bihar. We also found positively influencing variables, which are the number of migrant household members, personal information source, the social information source, as well as the formal information source. Now, with regards to traditional media, it has a negative effect to CASI adoption. And then other variables that are also positively influencing CASI adoption are access to extension, attendance to CASI workshop, and knowledge on CASI. Now, for the behavioral constructs, we found that self-efficacy and information-seeking behavior are positively influencing the farmer's decision to adopt CASI technology. We use the marginal analysis to interpret the CASI adoption and focused on the behavioral constructs. So as suggested by the marginal effects, a 1 Likert point increase in self-efficacy construct will increase the probability of CASI adoption by 13%. And similarly for information-seeking behavior, a 1 Likert point increase in information-seeking behavior will also increase the probability of adopting CASI technology by 3%. And finally, we compared the actual response for the self-efficacy and behavioral information behavior seeking of the farmers and compared it in terms of non-adapter versus adapter. The Likert scale is from strongly disagree to strongly agree. So for self-efficacy, these are the first 6 indicators. We found that there is a high rating for adapters in terms of self-efficacy compared to the non-adapters, and these are all significant. As well as these are the second set of the 6 indicators describing self-efficacy, and they are also significantly different, with adapters having high rating value. For the information-seeking behavior, we also found in terms of the 3 indicators that we use that there is also a high rating for adapter compared to the non-adapters, and these are all significantly different. So what are the implications of these 2 behavioral constructs that are positively influencing CASI adoption? First is that for self-efficacy, there are programs that promote self-efficacy and they may improve conservation behavior. So examples of this are the empowering feedback loops. In the context of CASI technology introduced in South Asia, we have the innovation platforms which provides feedback avenues for all the stakeholders, including the smallholder farmers. Now, in terms of information-seeking behavior, it suggests also that farmers with high information-seeking behavior will likely have high utilization of this information, which can improve their productivity and income. Now, we also found in our logic analysis that the social and formal information sources, the access to extension, and the CASI workshops are positively influencing the decision of the farmers to adopt CASI technology. And these are examples of information-seeking behavior of the farmers. So therefore, the agricultural universities and the extension workers have crucial roles in terms of scaling out the conservation agriculture technologies particularly in South Asia. These are the references that we use for this presentation. Thank you very much.